Hello there, my name is Santiago Pimiento and I am about to present our biggest innovation next to my partner Daniel Rodriguez. Together we are Pimiento Rodriguez Investment Group. Why that name? That name represents that we feel the need to invest in biggest innovations for the future. In order to innovate in the future, we needed to know what are we going to do? We did a brainstorm that included the next project ideas. Renewable sources of energy, protection of patrimonial heritage, water reservation and protection, antibiotics development for disease, architecture in the future, artificial intelligence, development of futuristic transport, development of advanced military weapons, global connectivity, development of virtual platforms in schools and universities, and hologram creation. After we thought about it, we decided that the chosen project to develop needed to be is the development of futuristic transport. The big question is why we chose it. Well, we have chosen the development of futuristic transport because we consider that this is a resource that in a few years it won't be so reliable as it is now. Due to this, we decided to develop this project in order to improve this public service and make it better because we believe that many people rely on public transport in order to get to other places, so it needs to be the better service for that people. We also needed to establish a mathematical connection with the aspect we selected to change the world. Taking into account that the idea selected was futuristic transport, we want to create a transportation method that is faster and efficient than any other type of transportation. That firstly doesn't consume that much energy and uses materials probably renewable that help both of the movement of transportation and help the environment. By knowing this, we need to understand the concept of the laws of velocity, speed and acceleration in physics in order to have an idea on what are we working on and to know what are the adequate materials in terms of surface area for the specific transport. Also, we can link it along with mass and weight of objects. In conclusion, we need to take into account speed, velocity, acceleration, and design of materials. It would be better if they are lightweight materials. We also needed to provide a framework for the mathematical concepts used for the field selected, such as environment, economy, social, cultural, and technical innovation. For this, we made sure to include the references using APA format. Remember, we developed three big areas through the trimester: geometry, numbers, and algebra. We also made sure to emphasize on physics, geometry, and the use of the best materials for this project. We have some references in the Word docs link. For this, we need to write an objective to cover, for example, like to describe the economy based on linear and quadratic functions. Well, we wanted to develop a fast and effective transportation method used on a geometry and physics concepts with environmentally friendly materials.
Develop the proposal by applying your mathematical topic. In detail, you have to include design of a train. So in this part, we put some examples of bullet trains, as you can see, and then we added our design of the train, our final design of the train. So we need the concept of math geometry in order to calculate the appropriate surface area in order to achieve two things. The first one, to make the lightest train possible that is able to recover a long distance in less time, and the possible environmentally friendly materials to use. That's why we need the surface area of the object. So we use the formula of a rectangular prism to calculate both the surface area and volume. So we used for calculating the average, the length of an average train, the height of an average train, and the width of an average train. Then according to those measurements, we use the concept of surface area and a volume. And the result, as it was a big number, we use scientific notation. Then for the front part of the train, that is in form of an isosceles triangular prism, we use the formula of an isosceles triangular prism. And we also used the measurements of a average of the front parts average of a train. We use the volume, surface area, and again the volume for calculating the front part of the train. Then the average speed of a train. Taking into account that our first concept to use is not mathematical but a physics concept, we need to use them in order to elaborate our project. In order for us to know what is the time that the train takes to recover a certain distance, we need the three concepts of speed, acceleration, and then velocity, in order to link them with the surface area of the actual train. So as you can see, we used a table that is divided in three parts: the track type, freight train, and the passengers. We used the class 4 with 97 kilometers per hour and the passengers of 129 kilometers per hour. In order for using this physics concept, we use the formula of acceleration, that is the change in velocity and divided in the time taken, and also the acceleration, that is final velocity less final velocity, we subtract the initial velocity divided in the time taken. And as you can see, there are the operations. So how much energy is consumed by the bullet train? At a constant speed of 300 kilometers per hour, it has a specific energy consumption of 28 WHPI kilometers. Source of energy. Bullet train uses a 25 kVAC overhead power supply, 20 kVAC on mini Shinkansen lines, to overcome the limitation of the 1500V direct current used on the existing electrified narrow gauge system. Power is distributed along the axles of the train to reduce the heavy axle loads under the single power cars. We also have the constant acceleration equations, as you can see. So explanation of every process and its relevance in the investigation. Example, you're looking for routes, you have to say why. Firstly, we use the concept of surface area and volume for compound shapes like rectangular prism and isosceles triangular prism. This was useful in order to know clearly what is the surface area of the wagon of our design of train, and the isosceles triangular prism formula helped us to know what are the measurements of the front part of the train. By knowing this, we can have an idea of what environmentally friendly materials we can use that help both the environment and the train. In addition, as a result of both the surface area and the volume were too big, we also use scientific notation. Secondly, we use the concept of physics of velocity, speed, and acceleration, and even constant acceleration in order to have an average acceleration of our design. For this, we use the formula of acceleration. This is an important factor in the report because by knowing the acceleration and the speed and the velocity, we can have an idea what types of materials does the train need. Thirdly, we investigate about the amount of energy the train will consume and which will be the source of energy. This is an important factor because in this way we can know for how much time does the train can travel with that specific source of energy and the amount it needs to recover certain distances. Sum up the proposal, writing the conclusions based on your result in the part 3. In conclusion, after finishing the mathematical framework about the concepts learned and the proposal we want to work on, we assume at the beginning that it was not going to be an easy task, not only because of all the things it was asking for, but because of the time that it needed and the amount of information to research. Just as we were getting more complicated as the topics became more dense despite the fact that we had already seen them. We were learning about the different measures of the train, the respective speed, the train tips, and many other things. That beyond being an investigation became a learning process, and it must be borne in mind that up to now we were going to the third point and there was still a long way to go. Taking into account that we wanted to develop an effective means of transportation that consumes less energy and uses environmentally friendly materials that applies concepts learned throughout the year, the result of the videos and other research we previously made were very accurate because by seeing this video and pages we had a context on what to look for. Plus, this video and pages were very helpful at the time of making the different operations and mathematical process. Lastly, the results on part 3 were better than we expected because our field of knowledge regarding the proposal and the objectives to cover could amplify it in a very positive way, and the mathematical framework shown in point 3 was the basis of all the report, showing that in point 3 things were done correctly. And in point 8 we use the references as you can see in here. Thank you.